So the topic of today is how to secure GraphQL APIs. And again, we'll try to dig into the best practices, but also focus on more advanced vulnerabilities to understand precisely what are the security implications of using GraphQL APIs, which are quite different than REST when it comes to security. On today's agenda, we will start by why is securing GraphQL that hard compared to more classic REST APIs? What are the differences in terms of architecture with REST APIs? Then we'll focus on the common GraphQL vulnerabilities. So again, what we observe at Escape by auditing many GraphQL endpoints on the internet, many production GraphQL endpoints, and especially from enterprise companies. And then we will focus on the best practices, so how to implement GraphQL security in a production context, how to create production-ready GraphQL APIs. And finally, I will present a bit the useful tools and libraries that exist on this topic. So first of all, why is securing GraphQL that hard compared to regular APIs? We created a report at Escape, which is called the State of GraphQL Security 2023. So we'll create an update of this report this year. And for doing this research, we scanned more than 1,500 GraphQL endpoints on the internet. So production GraphQL endpoints, more than 1,500 of them. And we compiled the result in a research report that is publicly downloadable. So you can download it using this QR code here. In total, we scanned more than 1,500 production APIs. It took us more than 416 cumulative scan hours, and we found almost 47,000 security alerts in total during this study. So that's quite a lot of security problems that we found. And that's almost 30 security alerts per GraphQL production API on average. So this is really an astonishing amount of vulnerabilities, and it highlights how difficult it is to secure GraphQL endpoints. But first of all, if we take a step back and we try to analyze why is GraphQL vulnerable compared to especially REST APIs or gRPC APIs. So GraphQL is a full-featured language. It's not only APIs, it's also a language, a query language, and a language has a lot of features. So in the case of GraphQL, we have queries and operations. We have fields that can specify the data that we want back from the API. We have directives that can transform the data that we get back. And we have parameters in the queries. We can alias and batch queries. We can create fragments, which are like functions in programming languages. So you see in GraphQL, there are many different features. There are many different tokens you can find in GraphQL compared to a classic REST APIs. And all of that, of course, creates a wider attack surface that can be exploited by attackers, malicious users, to create cyber attacks on the API. The second problem for GraphQL is that GraphQL, as its name suggests, is a graph. And when you're in a graph, you have a lot of different paths leading to the same resource. So if, for instance, I have a private Stripe token stored somewhere in my account, there are actually many different paths in the GraphQL schema that can lead to this token. So if I want to create the proper access control in this context, I need to ensure that, of course, all the paths in the graph are secured and that it's not possible to bypass the access control by finding a new path that none of the developer thought about during the development. And there are two problems when verifying the security of GraphQL APIs. The problem one is that classic testing cannot assess the business logic of APIs in general. So if you try to scan an API for security problems, most of your requests, and if it's automated, if you run a security scanner on an API, most of the requests will be blocked at the validation layer. So if I send, for instance, payloads that don't make sense, if I send an integer instead of an email, or if I send a string instead of like a specific token, the validation layer will block my request, and my test will end up not testing the actual code, but just being blocked at the validation layer. To solve this problem, at Escape, we created what we call the feedback-driven API exploration. So feedback-driven API exploration is a technology that is based on AlphaGo and AlphaZero by Google. So the technology that was used to beat the champion of Go game and chess using machine learning technique. And we observed that in the real life, APIs are quite similar to chess or Go game or other board games, because it's a state machine where you can do actions on them. So we adapted those ideas and this kind of algorithm to the exploration of API, to the test of API, and we created this algorithm, the feedback-driven API exploration, that allows Escape to generate legitimate sequence of requests, so requests that actually have data and parameter that make sense according to your code base and according to your API, to be able to test the API in depth. That is the first step. And the second step is recursively exploring all the paths in the graph. So we have an algorithm that explores recursively all the paths in the GraphQL, testing all the resolvers, even the deepest ones, in order to uncover the most critical, the most hard to find security issues in a fully automated manner. So what did we learn from that? Let's take a look at the common GraphQL vulnerabilities that we can find in our real-life context. If we talk about GraphQL-specific vulnerabilities, there are a few types of vulnerabilities that come back very often in the context of GraphQL, which are API brute forcing, denial of service, API schema leak, and unsafe public operations. So I will come back to what all of that means. First of all, let's talk about brute forcing API request. So in GraphQL, you have two features that are very useful for developers. Those are the batching and the aliasing. So batching is when you send multiple GraphQL queries in one single HTTP request. And aliasing is when you send several times the same field in the same query with a different name. They are pretty similar features, and they can be used to send one HTTP request with many different types of data and save HTTP calls. But this can be exploited, and especially it can be exploited by malicious users to bypass the rate limiting if the rate limiting is done at the gateway level or is done at the WAF level. Because for your server or for your web application firewall, only, like for instance, 10 requests will have passed through, 10 HTTP requests. But inside of each request, the malicious user has sent, let's say, 1,000 alias when it comes to GraphQL. So it actually has sent 10,000 GraphQL queries. This is especially dangerous if it's combined with the ability to log in with GraphQL, because in this case, you can perform a brute force attack on the login mutation of your GraphQL endpoint. So an attacker can create many aliases, and in one single HTTP request, the attacker can try many combinations of username or emails and password and try to steal accounts and guess the passwords of user accounts. This is very often overlooked, and we have seen this vulnerability several times in production GraphQL APIs from enterprise companies. So the consequences of not limiting batching and aliasing are stolen user accounts and possible sensitive data exfiltration without the web application firewall being able to block this kind of attacks. The second problem is GraphQL bombs. So GraphQL bombs is an attack that exploits the ability to create aliases with file uploading. It happens that when you upload a file with GraphQL and you create an alias of this file in the same query, the server will copy the upload as many times as there are aliases. So if you create 1,000 alias of a 1 megabyte file, it will actually store 1 gigabyte file on the server with a just 1 megabyte request, which is a huge problem and can create very easy denial of service. So we created a full blog post. This vulnerability has been discovered. So it's a 0-day that was discovered by Escape security research team. And a lot of GraphQL servers are vulnerable to it. I really encourage you to read this blog post about how to create GraphQL bombs and how it can be avoided in your environments. So the consequences of using GraphQL bombs and aliases can be stealing user accounts, exfiltrating sensitive data, and of course, using GraphQL bombs to actually just crash the server and create a denial of service that is very hard to fix. Let's speak about another problem of the GraphQL language itself. So in GraphQL, you have a feature that is called the fragments. The fragments are a piece of logic that can be shared between multiple queries. It's very similar to a function in regular programming languages. But just as a function, well, what happens if you create a fragment that calls itself? So a recursive fragment. Well, it's just like in a programming language, when you create a function that calls itself, it can create an infinite recursion loop. And if you do that on a real-life production GraphQL API, you can just crash the GraphQL API and create a denial of service by creating an infinite recursion loop in any production GraphQL server. And when we discovered this vulnerability, we have found that an astonishing amount of GraphQL server, actually more than 80% of the production GraphQL server on the web for public APIs were vulnerable to this attack, and so were vulnerable to easy denial of service and could have been crashed by anyone that knew about this vulnerability. It's actually not that easy to fix because understanding when you send a query to a GraphQL server, understanding that this query will create something recursive is not that simple. So even when it was fixed in one server, it was still existing in many different GraphQL servers, including in Rust implementations, in some JavaScript implementations, in some Python implementations. So we had to actually go to all the maintainers of all the GraphQL libraries and explain to them how to fix this problem. And this is what we did with the Escape team. So we collaborated with most of the maintainers to help them fix this problem at the framework level instead of in the code of the developers. So exploiting this vulnerability can lead to different consequences like API unavailability. So the API is crashed, or even API shutdown. The server is completely stuck and it's not possible anymore to make any request to the service. Okay, another critical vulnerability that we found very often in GraphQL is GraphQL leaking its internal schema. So if you are in this event, you probably know that GraphQL is an introspectable kind of API. So basically, you can, if you find a GraphQL endpoint, you can ask this GraphQL endpoint for the schema, the API schema, or for what data you can ask, we can fetch from this API. In some cases, the data is sensible and you don't want any person externally, any external user to be able to see the internal schema of your GraphQL API, the internal structure of your API. So you deactivate the introspection. You deactivate the ability to explore the schema of the API. But there is a feature in GraphQL which is called the field suggestion, and it's a feature that when you type a GraphQL query, if you made a typo, like create session instead of create session, the GraphQL server will send you back a message telling, did you mean create session, create user, or something similar? So there is a suggestion of the data that you can fetch. But well, if you use this suggestion feature and you create a smart code snippet that can iterate through random field names and analyze the message of the GraphQL server, you are actually able to build back the full internal API schema from the GraphQL server. So here, the schema that you see on this slide is a real-life production GraphQL endpoint with introspection deactivated that we were able to build back with a small open source script called Clairvoyance that exists on GitHub and that helps building back the schema when this vulnerability exists. In this context, it was even worse because the company that was using this GraphQL endpoint, they thought they were secure because they have deactivated the introspection capabilities. So they had an update admin mutation that was actually not protected by any form of authentication because it was supposed to be hidden. And we were able to find this update admin mutation, and we were able to change the admin password and username without any authentication. So it was a complete takeover of the platform and the GraphQL APIs just because of the combination of bad authentication plus API schema leak. So the consequences of this vulnerability are, first of all, easy access to unauthorized functions, so understanding the attack structure, possible attack structure, and easy compromission of the API when combined with other vulnerabilities, such as authentication problems. So if you combine authentication or authorization problems with leaking API schema, then you are offering a very easy territory for hackers and malicious users to steal a lot of your data and create cyber attacks. Yeah, and finally, another problem that I wanted to discuss is that a lot of GraphQL engines are very verbose. So when you see an error message, there is a stack trace with the details of what caused the problem on the server side. And very often in those stack traces, there are indications on the internal libraries and software components that you use. And it's then very easy for any malicious user to look on the internet and find potential CVEs or vulnerabilities that exist in your application. So we found that more than 10% of GraphQL endpoints had debug mode and stack trace that were enabled in real life scenarios, which created a huge problem and is a huge security risk. Okay. So I already covered this, but I'm going to say it again because this is very important. Very often in GraphQL, there are problems about access control. And very often, for instance, we can see mutations that are not restricted to authenticated users. So it means that any user, authenticated or not, can run a mutation and change the state of the API. And this is especially the case because GraphQL can run mutations with other things that post request and can change the state, for instance, with get request. So this can be a problem. And last but not least, injections still exist in GraphQL. So we detected during the study of all the GraphQL public GraphQL endpoints, we detected more than 16 SQL or no SQL injections in the wild. So in production GraphQL APIs, we detected 1 bash command injections and at least 3 server-side request forgeries. So those vulnerabilities still exist in GraphQL endpoints, and you should still be aware that this can happen in your application if it has not been developed with the latest security countermeasures. So how does OWASP Top 10 reflect in prod-ready GraphQL apps? If we take a deeper look, we can see that GraphQL is very vulnerable to dose and complexity issues, which are API 04 and restricted resource consumption. GraphQL is very prone to access control, authentication, authorization problems because it is a graph which are API 1, BOLA, API 2, broken authentication, API 3, broken object property level authorization, and API 5, broken function level authorization, also named BFLA. And finally, a lot of security misconfiguration and information disclosure problems, which is mostly due because federated GraphQL apps often forget to catch error messages from underlying APIs, and also because a lot of GraphQL endpoints have development features enabled in production. So what does that mean for the security of GraphQL? If you want to create secure GraphQL APIs, you have to be aware of mitigating the risk due to GraphQL specific features, being very efficient at handling authentication and authorization because of the graph nature of GraphQL, and being careful about deactivating all development features and avoiding error messages or error messages that are too verbose in production, because that discloses a lot of information from the underlying APIs. So if we try to summarize this as best practices, so how do we implement GraphQL security efficiently? On the security side, the first thing that we need to do is take back control of the API attack surface. So we cannot secure what we don't know about, so we need to have a precise API inventory. Any security engineer involved in the security of API should be able to answer the following questions. How many API does my company expose externally? Which of them are critical to the business or manipulate, handle sensitive data? Do we have any development endpoints exposed on the internet? And do we have unnecessarily exposed endpoints? And I have seen in many companies, especially companies that are very tech savvy with very modern teams, they still expose development endpoints that disclose a lot of information on their stack, on the security vulnerabilities that could exist in production. So this is a problem that exists both for large enterprise and also for smaller businesses that have a limited amount of APIs, but that still disclose too much information to the internet. Okay. Do some GraphQL API threat modeling. So if I was an attacker, how could I use GraphQL APIs to threaten the business? And I assume that this presentation can help you see from the point of view of attackers. Like when I see that a business uses GraphQL, I will try all of what I said during this presentation, like denial of service, data exfiltration, and so on and so forth. And talk with the developers. Talking with the developers to understand how they build their APIs, raise awareness on the API security risk, and especially give examples. So I guess that some of the examples that I gave during this talk can be useful for the developer to understand how the features of GraphQL can be applied to creating cyber attack to be actually a risk for the safety of the API and the company's data. And finally, implement best practices throughout the API lifecycle. So that means implement an API gateway, implement secret scanning, and especially on front-end repositories, because very often we see API secrets ending up in front-end repositories. Test every API release, so GraphQL and REST for OWASP API top 10 and business logic flows. And if possible, you can do it as early as in the CI/CD, so the developers don't lose time going back to former code, but they can have instant feedback on the security of what they're building. And finally, have a proper security monitoring for live API traffic. Most of the monitoring vendors now have also security monitoring functions, so you better use it. That's really a good added value on your security stack and application security stack. On the development side, there are many things that developers need to care about, and there are many libraries that can be used to improve the security of GraphQL endpoints and GraphQL APIs. So of course, limit access control with authorization and proper authentication. So authentication is very easy to achieve, but authorization is a bit more complex. So it can be good to do it well, and also to test it properly with the security team. Validate all your input. So there is a nice library called GraphQL Scalars that has been published by the Guild, and it helps validating all the parameters in your GraphQL APIs. I really encourage you to validate all the input parameters because it greatly reduces the attack surface from your GraphQL endpoints. Implement rate limiting to block brute force attack. So there is a GraphQL limit plugin, but there are other plugins that are similar to monitor and enforce rate limiting for GraphQL, and implement depth limiting. So we published a package that is called GraphQL Armor that is very powerful, very simple to implement for JavaScript GraphQL server, and it limits the depth, it limits the rate limiting, it limits the cost. It really has many security features to harden your GraphQL APIs very quickly in a single line of code. I greatly encourage you to check it out. It's a really nice open source package created by the Escape team. And finally, you have schema whitelisting. So this is also called persisted queries. And this allows you to restrain the amount of queries that can be done to the only specific queries that your front end actually uses. There are different packages like Persist GraphQL by Apollo or GraphQL CodeGen from the Guild that can auto-generate a list of approved queries at build time. This is a great security measure, and it only works for GraphQL APIs that are consumed by front-end and not public GraphQL APIs. But still, it's a great way to reduce your attack surface. And finally, of course, limit the cost of GraphQL queries. So this is linked to depth limiting and rate limiting, but this is really something that can limit the ability of malicious users to perform advanced attack on your GraphQL endpoint. Another thing, this is not GraphQL specific but we have observed it a lot in the past month when doing our research. You should be aware of front-end build systems like Webpack, because sometimes they tend to package the secrets and the environment files inside of the front-end code. So for instance, you have all your CI/CD tokens and all the sensitive environment. Webpack takes it and ends up building it into your front-end code. So it's accessible to everyone on the internet. We found many credentials, private GitLab or GitHub tokens, or even Stripe tokens that were embedded in the front-end JavaScript because of that. So be careful about this and be sure that your build systems exclude the environment files and environment variables and do not include them in the front-end code. Okay. So a few useful tools that you might like about GraphQL. So we gathered the public awesome GraphQL security list. So this is like a collaborative, curated list of cool security tools for GraphQL, which includes authentication and authorization middlewares, security middlewares, security tools that you can use, and so on and so forth. So feel free to check it out and even contribute. And of course, if you are using any JavaScript or TypeScript GraphQL server for your applications, I really encourage you to implement GraphQL Armor, which is a free security middleware for GraphQL applications that provides out-of-the-box security best practices for your developers, including alias limit, character limit, cost limit, depth limit, and so on and so forth. So this is something that we collaborated. So this is the Escape team that created this package, but we collaborated with the Guild and with Apollo and the GraphQL Foundation to make it available for all GraphQL servers. And finally, we've created a few other tools that you might like, including the Escape Tech Academy, which is a free API security academy for GraphQL developers. and it includes a full in-browser development environment that you can use to practice GraphQL security on the server side and learn by doing. Again, the Academy is also open source, so you can add your own lessons and collaborate with the community to practice GraphQL security and to make your developer practice GraphQL security. Okay, so that is the end of this presentation. Thank you for being here again. And I think we still have a bit more time, so I'm looking forward to answer any of your questions. Have most frameworks added the ability to disable the "did you mean" error responses from Daniel? So this is an interesting question because the GraphQL landscape evolves very fast. The last time I checked, I think it was actually not possible to disable it in a few GraphQL servers, including Apollo, but I think they fixed it in the most recent versions. So I think now for JavaScript GraphQL server, it's possible to deactivate it. And in any case, you can use GraphQL Armor that will deactivate it. For GraphQL servers in other language, this is a good question, but I assume they would have done it as well because it's a known vulnerability now. Okay, any other questions? So this is actually a great question. So there is a middleware. I think it's in the list of awesome GraphQL security, so you can check there because there are a lot of those middlewares are existing in this list. So really, like it's really hard to have a great answer to this question. The strategy that we have implemented at Escape is to use role-based authorization on each resolver. So this is what we do because our own platform is based on GraphQL APIs. But it depends on if you use role-based authorizations or rule-based authorization. We have done it at the resolver level, and I know that there are middlewares that exist for implementing it properly. I would check the awesome work from the guild to check about that. The guild has a pretty good amount of great GraphQL middlewares for implementing authorization and authorization. Yes. Okay. I think I'll. This is a great question. So subscriptions are quite interesting. So even if the GraphQL ecosystem is a bit moving away from subscriptions, subscriptions are actually mostly based on WebSockets. So they open a wide range of new vulnerabilities. One of the things that we noticed with subscriptions when doing research is that very often they created new access control problems. And we noticed very strange behaviors among code bases. One example that I can give you is that when you requested, for instance, the list of users through the normal query, you had only access to basic information like the email. And when you requested the list of users from a GraphQL subscription, then you had access to much more information and much more deep in the GraphQL schema. So it appears that the main problem with GraphQL subscription is that they are often overlooked by security people because they are based on WebSocket. And this way, security teams do not test them as thoroughly than as a classic GraphQL queries and mutations. So no 0-day specifically for GraphQL subscriptions, but a lot of misconfigurations and a lot of access control problems. for the authorization, I really encourage you to read the work from the guild, and we also have this kind of article on the Escape blog. So yeah, access control best practices and object level authorization. So those are things that we also have written about on the GraphQL Escape GraphQL security blog. Any other question? Is testing GraphQL subscriptions as straightforward as with queries and mutations? I see this question in the chat. So yeah, actually, this is this is a great question. No, it's not. It's not, because subscriptions are based on WebSocket. An overwhelming amount of tools designed for security are not designed for GraphQL in the first place, but also not designed for WebSocket, but more for HTTP APIs. And one of the huge problems that you encounter when you try to test the security of GraphQL endpoints is that most of the tools that were created for testing APIs or testing web services were designed for testing HTTP services, and they do not support GraphQL properly. They treat GraphQL as a sequence of HTTP requests, whereas GraphQL is something completely different that is independent from the HTTP layer, that is a specific language. And this is one of the reasons why at Escape we created our own testing engine from scratch. So we didn't base it on OWASP. We didn't use any open source tool or like Nuclei. We created really our own engine that would be able to take into account this specificity for GraphQL and not test it as a regular HTTP API. Okay. Any other questions? Great. So I think we can close the session. So thank you for coming today and for hearing this talk. I hope that you enjoyed it and that you learned a lot about the security of GraphQL endpoints. GraphQL is an awesome technology. It has a lot of powerful features, but with great features comes great responsibility, and especially when it comes to security. We need, as security engineers, as developers, as managers, ensure that the GraphQL endpoints that we create and that we open to the internet are secure. So I hope this talk could have given you a bit more information about how to do it properly. If you want more information, feel free to reach on to go on Escape's blog, or also to try Escape, because you can try Escape for free to run a sample test on your GraphQL APIs and try to find vulnerabilities and see where you stand from a security point of view. Thank you again, and we will share, I guess, the slides so you can review all the findings later and take a look at the presentation. Thank you, everyone. This was Tristan from Escape for GraphQL Security, and I wish you a great end of the day.